Good morning, students. Chapter heading Continuity. Once again, the meaning of continuous. If the function fx is continuous at x equal to a, the condition is LHL equal to RHL equal to value of the function at x equal to a. Write down limit x tends to a minus fx is equal to limit x tends to a plus fx is equal to f of a, or limit h tends to 0 f of a minus h equal to limit h tends to 0 a plus h is equal to f of a. Understand? In this class, we can do more problems about this continuity. Right. Discuss prove that the function fx equal to x raised to n is continuous at x equal to n, where n in natural number, n in n. Write the solution set. Here, fx is equal to x raised to n. Our aim is to prove that this is continuous at x equal to n. That means the first one, f of n. How can you find f of n? F of n means, in the place of x we put n. Therefore, the value of the function at x equal to n is n raised to n. Now we can take limit, limit x tends to n plus fx. That is limit x tends to n plus, what is your fx? X raised to n. Here we will apply the second method by putting x is equal to n plus h. Right. By putting x is equal to n plus h. Therefore, limit h tends to 0. H tends to 0. In the place of x we put n plus h, the whole raised to n. We know that h tends to 0 means n raised to n. Therefore, the answer is n raised to n. Okay. Now we can take limit, limit x tends to n minus. That is, limit x tends to n minus fx. Okay, that is limit, limit x tends to n minus x raised to n. Now look here, by putting, putting x is equal to n minus h. Putting x is equal to n minus h. Therefore, limit h tends to 0. Limit h tends to 0. N minus h the whole raised to n. When we put h tends to 0, here also the answer is n raised to n. n raised to n. F of n is equal to n raised to n. F of x tends to n plus is n raised to n, and f of limit x tends to n minus is also n raised to n. Then how can you write below? Write limit, write the step, limit x tends to n plus fx is equal to, right, limit n tends to n minus fx is equal to f of n. Therefore, function f is continuous at x equal to n. The function fx is continuous at x equal to n. Write down the next question. Is the function fx is equal to x square minus sin x plus 5, x square minus sin x plus 5, continuous at x equal to pi. The question is, if the function fx equal to x square minus sin x plus 5 is continuous at x equal to 5. All of you copy once again this fx equal to x square minus sin x plus 5. Okay. Here continuous at x equal to pi means the first one f of pi, right? F of pi is equal to pi square minus sin pi plus 5. Can you say what is sin pi? Sin pi is 0, therefore the answer is pi square plus 5. Pi square plus 5, right? Then we can find limit x tends to pi minus. You can put pi minus first. Pi minus fx. Limit x tends to pi minus, what is your fx? X square minus sin x plus 5. Okay. That is, put x is equal to, say the answer, put x is equal to, here the limit is pi, therefore pi minus h. Here put x is equal to pi minus h, therefore limit x tends to, h tends to 0, right? H tends to 0. In the place of x, put pi minus h. Pi minus h the whole square minus sin pi minus h plus 5. Okay. In the place of x, we put pi minus h. When you put 0, h tends to 0 means this tends to pi minus 0, the whole square means pi square. All of you agree? Pi square. Here also sin pi is 0, then plus 5. Therefore, the final answer, limit x tends to pi minus, answer is pi square plus 5. Then what is the next one? Limit x tends to pi plus. X tends to pi plus, what is the function? X square minus sin x plus 5. Here put x is equal to pi plus h. Put x is equal to pi plus h. Therefore, limit. When you put x is equal to pi plus h, you have to write limit h tends to 0. H tends to 0. In the place of x, we put pi plus h the whole square minus sin pi plus h plus 5. Therefore, when you apply h tends to 0, here also you will get pi square plus 5. All the three values are same. Therefore, we can write we can write limit x tends to pi minus fx is equal to limit x tends to pi plus fx is equal to f of pi, isn't it? Here x is equal to pi. Therefore, the last line is, therefore, f is continuous at x is equal to pi. Therefore, f is continuous at x is equal to pi. Okay. Write the next question. Show that the function fx is equal to 3x minus 2. The condition is important. If 0 less than x less than or equal to 1. The same function fx takes the value 2x square minus x if 1 less than x less than or equal to 2. And the last one, the same function fx take 5x minus 4 if x greater than 2. This is the question. Our aim is to show that this is continuous at x equal to 2. Understand? Continuous at x equal to 2. All of you look at the board. First you have to find f of 2. That is the main thing. F of 2 means the value 2. Where x takes the value 2. All of you look at the board. This is less than or equal to 2 means fx takes 2 in the second condition. 2x square minus 2. That means f of x is equal to, above right, f of x equal to 2x square minus x. There the function take x equal to 2. Therefore 2 into 2 square minus 2. 4 into 2, 8 minus 2. Is it 6? All of you check the value. Is it 6? Yes. Next our aim is to find at x equal to 2 is our aim. Therefore, limit x tends to 2 minus fx. Right? Very simple. Limit x tends to 2 minus fx. 2 minus means, all of you look here, this is 2 minus. Less than 2 means this x takes, function takes this condition. 2x square minus, right? That is limit x tends to 2 minus 2x square minus x. Then put, if it is 2 minus, how can you write put x is equal to 2 minus h? X tends to 2 minus means put x is equal to 2 minus h. If x tends to 2 plus, you have to write x equal to 2 plus h. Okay. Then limit x, no, you can write h tends to 0, 2 into 2 minus h to the whole square minus of 2 minus h. 2 into, when you put h tends to 0, 2 square into 2. 4 into 2, 8 minus 2. Agree? That is also 6. Put h is equal to 0 in this line. H equal to 0 and simplify. Then you will get the answer 6. What's the next condition? Limit x tends to 2 plus fx. You can write this 2 plus first or 2 minus first. Our aim is to prove that LHL equal to RHL equal to f of a. 2 plus, limit x tends to 2 plus, all of you look at the board. The third condition says fx takes 5x minus 4 if x greater than 2. 2 plus means above 2, isn't it? Therefore, in that case, fx takes, that's a very important condition here. You know which function that x takes. Here, if it is x greater than 2, then fx takes 5x minus 2. Therefore, limit x tends to 2 fx means 5x minus 4. Then put x is equal to 2 plus h. Put x is equal to 2 plus h. Limit h tends to 0. All of you agree? 5 into 2 plus h minus 4. What is when your h tends to 0 means 5 into 2, 10 minus 4, that is also 6. Got the answer? Then below write limit x tends to 2 minus fx equal to limit x tends to 2 plus fx is equal to f of 2 equal to, here the answer is 6. You can write that. Then what is the last line? Therefore, the function f is continuous at x equal to 2. The function f is continuous at x is equal to 2. Okay. Take the next question. Fx takes x plus 1. The value x plus 1. Condition is if x greater than or equal to 1 and if x less than 1, the function takes x square plus 1. Our aim is to prove that this is continuous at x equal to 1. All of you write this line. Being a polynomial, this function is a polynomial for x greater than 1 and x less than 1, f is continuous. We know that all the polynomial functions are continuous. All the polynomial functions are continuous. Now our aim is to prove that this is continuous at x equal to 1. That particular point. Okay, start. What's the first one? Fx is equal to, both values are there. At x equal to 1 means f of 1. F of 1 means where that function take 1. Look at the board. Equal to 1 means here x plus 1. That means 1 plus 1 is equal to 2. Got it too? Okay. Then next one is limit x tends to 1 minus. 1 minus means less than 1. All of you look at the board. Less than 1 means the function takes x square plus 1. 1 minus fx means limit x tends to 1 minus x square plus 1. X square plus 1. That is, put x equal to 1 minus means 1 minus h. Okay. Then limit h tends to 0. 1 minus h the whole square plus 1. Put h is equal to 0. That's a step here. Put h is equal to 0 means 1 square 1 plus 1, this 1. 1 plus 1 is equal to 2. All of you got it? Say yes or no? Yes. Very good. Now our aim is to prove limit x tends to 1 plus. 1 plus, what is the meaning? 1 plus greater than 1 plus 1. Therefore, 1 plus fx means limit x tends to 1 plus x plus 1. Then now put x is equal to 1 plus means 1 plus h. Okay, then limit h tends to 0. If you put x equal to 1 plus h, then write limit h tends to 0, 1 plus h plus 1. H tends to 0 means 1 plus 1 equal to 2. Okay, then write limit x tends to 1 minus fx equal to limit x tends to 1 plus fx is equal to f of 1 equal to 2. Therefore, f is continuous. F is continuous at x equal to 1. F is continuous at x is equal to 1. Right, one more question. Copy the next question. Fx equal to x square minus 3. Condition if If, that condition is very important. If x less than or equal to 2 and if x greater than 2, the function takes the value x square plus 1 at x equal to 2. At x equal to 2. What's the first line? Being a polynomial function, for x less than 2 and x greater than 2, f is continuous. All the polynomial functions are continuous, but our aim is to prove that at a particular point this function is continuous. That is the important point. Okay. Then all of you write, what is f of 2? F of 2. Now you can do by yourself. Are you confident? Yes. F of 2 means the function takes x square minus 3, isn't it? Fx is x square minus 3 at a, therefore 2 square minus 3. What is 2 square minus 3? Change the question, all of you change the question. Here this is x cube minus 3, not x square minus 3. All of you change the question. Fx takes x cube minus 3, x less than or equal to 2 and x square plus 1 x. Then 2 cube minus 3. What is 2 cube? 8 minus 3, that is equal to 5. Change the question. X cube minus 3. That is, what's the next one? LHL. LHL means left. Therefore, LHL means x tends to 2 minus fx. Look at the board. Where is 2 minus less than condition is in the first line. Isn't it? X less than 2 is the meaning 2 minus. Therefore, limit x tends to 2 minus. All of you write that function there. X cube minus 3. Okay. Now put, say loudly, put x equal to 2 minus h. That is limit h tends to 0, 2 minus h the whole cube minus 3. Here when we put h tends to 0 means 2 cube by 8 minus 3, that is also 5. Then RHL. What is RHL? Limit x tends to 2 plus fx. 2 plus means, look at the board, 2 plus means the function takes the value x square plus 1. Function takes the value x square plus 1. That is very important, all these steps. X tends to 2 plus x square plus 1. Now put x is equal to 2 plus h. Therefore limit h tends to 0, 2 plus h the whole square plus 1. When you put h is equal to 0, 2 square, 4 plus 1, 5. Very interesting, isn't it? 2 square plus 1 is 4 plus 1, 5. Then what is the last sentence? Limit x tends to 2 minus fx equal to limit x tends to 2 plus fx is equal to f of 2 equal to 5. That means the function is continuous at x is equal to 2 and has no point of discontinuity. In this question, no point of discontinuity. All of you understand? Okay, study well. In the next class, I will explain the remaining portion. God bless you.